just starting. Hi. You see the little girl in the back? This is Vida. This is my daughter. She's visiting Oslo today, thanks to the amazing organizers. So thank you very much for having me and my family and all my friends here. Vida she's very kind and a bit fearless and curious. She's, I guess, like any 6 years old, but she's very curious, very, very, very curious. But she's not the only one. I mean, we are all very curious. We came here to listen to talks and new technologies, and our curiosity drives us to actually solve problems. We are makers above all. We write code to help people, and we write useful software to solve real issues. But today I would like to invite you to write useless code just for fun, just because we can. I would like to talk about coding art, about just experimenting with technologies and creating, having fun. My name is Mathieu Henri. I am an engineer at Microsoft, and I go online as p01. The things you see in the background are some of my projects. They are all with some interactivity, some sound, some inputs, and they are all around 4 kilobytes, 1 kilobyte, and down to 64 bytes, all with web technologies. And the silly small size comes from the fact that I love procedural generations. Procedural generations is about creating assets with code, and it feels really good to create anything with code. And I also come from the demoscene, which is a subculture which started about 35 years ago, but aims to actually push the technical and artistic limits of any platform. So this is what I try to do. And after making this project, I think the key to create something, to create art, is to develop a creative mindset. It's about abusing the standards, like knowing them enough, so that you know what is available and what they're built for, and you also think of ways to abuse them and twist them to your will, and gaining a visual understanding of mathematics. You shouldn't be scared of big formulas. It's just a language to express some concepts, and it's much better to understand these concepts and actually be able to play with them and have fun with them than to know a big formula. So let's take a small example. I hope you can see the little maze at the top, made of diagonals. This maze is entirely made of these 66 bytes, which you see on the screen. What it does is when the user moves the mouse around, we append one of 3 random characters to the page. This is the event page X modulo 3, which you see, that picks the random character based on the mouse coordinate. What you don't really see is, in the string, we see a slash forward and backward. What you don't see is the zero-width white space, which is there. This zero-width white space gives the browser an opportunity to insert a line break. So otherwise, we would just get one long line of slashes and nothing else, just one line. But inserting this zero-width white space, which is kind of strange, actually gives a chance to break and create this pattern. So you see, it's not trivial, but once you know these things, they become really helpful. So to make art with code, you usually know framework, or to think about frameworks. You will probably deal a bit with numbers. Some shiny colors are nice, some music is really nice too, and of course you have to think about your render loop, how you will render the different frames. So about frameworks. There are many, many, many frameworks available out there, but when I make art projects, I like to not use any. I like to use no framework, no library. So I just focus on what I'm trying to solve and nothing else. I don't get distracted with all the capabilities of frameworks. And in the same idea, I try to limit myself to one drawing primitive and one formula. This idea of one formula is just, you should have one common thing that drives the visuals and the sound if you have visuals and sound. That way things stay in sync and it makes a cohesive whole. So to do animations, you will, or any kind of rendering, you will certainly play a bit with trigonometry. Trigonometry is a big word to talk about things moving along circles. Don't get scared about this. And we are making art, we're not making like mission critical or life critical programs. So we can use approximations like these ones. You probably heard at school that 22 divided by 7 is very close to pi. And that's good enough. I've used these approximations in some of my projects, and no one complained. It was fine. And numbers in JavaScript and many other languages are specified with this RFC, or with this standard, IEEE 754, which says that numbers are represented in binary. As 0 and 1, that basically represents a composition of powers of 2 and their fractions. So that leads to what is called floating point errors. In JavaScript, if you do 0.2 plus 0.1, you don't get 0.3, you get 0.3000004, which is a bit strange, but it's normal because 0.3 cannot be expressed exactly with combinations of powers of 2, fractions of power of 2s. So that's a bit annoying. And when you do a loop, a simple loop, from 0 to 10 with an increment of 0.1, you don't ever end at 10. You end at 10, 0, 9, 9, 9. That's because 0.1 it cannot be expressed exactly as a fraction of power 2. So it can bite you if you don't think about it. But if you're aware of it, you can actually use it to your advantage. If you have this same loop, but from 0 to 10, but with an increment of 1 divided by 8, which can be expressed exactly as a power of 2, or a fraction of power of 2, all the numbers along that loop can be expressed exactly. And the loop ends at 10, exactly. That gives some nice properties. Like if you want to check if a number is an integer, you just do I modulo 1, and it will just give you a fractional part. And because all the numbers can be expressed exactly, integer numbers will give you 0, no fractional part. With an increment of 0.1, that will not work. Playing with colors, it is really tempting and really nice to use the HSL notation to rotate the colors over time. And HSL, you basically set the hue of your color along the color wheel, which we see here, and then saturation and luminance. It's really nice, but screens render in red, green, and blue. And the browser has to parse this syntax, then convert to RGB, and then render the colors. And it takes some time. You really notice it. But instead, if you look at this color wheel, which we see here, and think that it is actually red, green, and blue, it's not one wheel, it's 3 wheels on top of each other. And it's actually 3 wheels on top of each other, just rotated by 1/3 of a circle. And if you do the math yourself, don't get scared. It's just the same thing, but split equally across a circle. It is up to 1 order of magnitude faster than the HSL notation. So you see a problem, and you have to think about it and see how you can solve it better. It's nice to add some motion blur, and it can be as simple as actually not clearing completely the screen when you do your the next frame. In this case, I just draw a black rectangle, but at 10%, and you see that leaves a nice trail behind it. And to get shiny colors, in CSS, we can use box shadows. That just works for shapes. OK, it's a bit difficult to see, I think. That's great. And with Canvas, we can use shadow blur. Shadow blur and shadow color in Canvas, they are not just about shadows. They're about drawing the same shape blurry. It's a bit of a misnomer. So if you just set a shadow color and a shadow blur, which gives a radius of a shape, it will draw the things with a shadow or a glow. So we've covered the frameworks, numbers, and colors. And now let's talk about music. So to do music on the web, there are 2 ways. There's the audio element, which is very simple. You load the sound and you play it, and that's about it. Or there's the web audio API, which lets you build a whole graph of audio nodes which you connect together, and you can have filter nodes or source nodes and distortions and so on. And there's even a script processor node, which actually gets a process event, audio process event, and lets you actually program music, like with JavaScript on the fly. And it's super powerful. And the audio API, web audio API, also gives you access to the audio data. In the background, it does a Fourier transformation. So you see with these 5 lines of code, we create an analyzer node, then we connect it to audio context, and we get access to the data, and we can draw this curve that represents the frequencies of a prelude by Chopin. And for the render loop, to display the next frame of your animation, obviously the right way to go is to use request animation frame. We've all heard about it, and it kicks in whenever the device is available or ready to render a frame, without and taking care of that the viewport is visible, that the device is plugged on the battery, and so on. So it does really nice things for us. But if you're a bit naughty and you already use the script processor event, script processor node to create your music on the fly, you can abuse its event, the audio process event, and hit two birds with one stone and render the visuals and the sound at the same time. But I have done it a couple of times, and it works. So you see, it's a few tricks, but it all boils down to having this creative mindset about knowing and abusing the standards and getting a visual understanding of the mathematics of what is going on behind some concepts. So this is how we can go about coding art. And now I would like to make some art with code with you right now. So just going to drink a bit, and then we will code. Right. So that's next slide. Sorry. Come on. That. Okay. So when I live code, I start from the most simple setup. So I start with just a text editor, a browser open all the time. Done, nothing else. So I have this small markup page, which basically has a canvas, which is full size, and a small overlay, which is like a small gradient repeated. That's about it. And it just loads a live.js file. So we start. I have some notes on my phone too. Right. So today I would like to actually load music that a friend made and play with its audio data and render, have fun with the audio data. So how do you my audio? Just create an audio element which load. So is the text big enough? Okay, perfect. And we will autoplay and loop. Can you, okay, can you hear? I hear more from my laptop. Okay, so to get access to the, first also I will get also the context of a 2D canvas. My canvas is called C, so I can just do this. So I will be able to render things. And it's really nice to get access to, or to set the width to the width of the window, the height as well. Right. And I will need frame index will be useful. And a function to render the next frame, or to render a frame, which will receive a number of milliseconds as argument, and I can call it with starting at 0. And we can do console log. Yep. And we need to call request animation frame on this function to render the next frame. So we see the number of milliseconds increasing here. Right. But I say I want to play with the audio data, so I need an audio context and an analyzer node. You see so I need to create an audio context. I need to create a source So I need to actually pipe the audio element into the audio context. So for that, I do my audio context dot create media, damn it, media elements source. And I need to connect it to destination of the audio context. So now, it doesn't sound like it, but now the audio element is actually piped through the audio context. So if I get, now I can create an analyzer node. Sorry. Okay, thanks. So I was confused, I was not getting the auto-completion from VS Code. So I can set analyzer dot. So this is to say how many frequencies I want to look at, and I will just look at 256 for now. I will do. And if I do, okay. That should make Visual Studio Code happy and give me auto-completion to set everything as constant. So I need to connect the source, this one, to the analyzer node. And so, and here, if I want to get the audio data, I will get an array. The audio data returns, it can return an array of floats or an array of uint8. And that will be from the analyzer node. And here's the length that we get back. So in the loop, I can call analyzer dot get byte frequency data, and I pass it the array of bytes that it can populate with the audio data. And let's, bless you. First audio data. So which line? Oh yes, oh, sorry. Okay. So now I would like to actually draw this. And to draw this, I need first to clear the canvas. Clear. And to clear the canvas, you can just set the width, set it back, and I will just reset the whole canvas. And now let's draw the audio data. And I will get length, which will be audio data. Right. So I would like to draw it as a line. So I need to begin the path. At the end, I need to call stroke to actually draw a stroke for the path. And also, it would be nice to set a color. So stroke style equal. Yeah, VS Code really wants this as constant. Because we use it only once, I can use VHSL notation. And I can do a number of milliseconds divided by something. So I will just get a very saturated color in HSL, which will shift in hue over time, so that we draw it in a nice color. And what we can do here to draw our audio data is first we need to get the audio data and the index. And this is an array of bytes of 8-bit integers, which goes from 0 to 256 or 255. So I want to use values from 0 to 1. It's just more convenient. And we have our index in the audio data, which I want to map to 0 to 1 and then to extend to the whole screen, capital W. And then I will do times h. Of course. So you see the line at the top. It looks a bit strange like that. Let's put it upside down. And let's try to actually scale it, because it takes the whole screen. That's not really nice. And this thing, it probably looks familiar. It looks like the equalizers on the old car stereos. So let's use that naming. So let's set equalizer width. Let's say it will take half the width of our canvas, and let's also scale it vertically. So equalizer height, of course, let's say 1/4 of the height, so that I want to actually center it and that it doesn't take too much space. So I will do, if I want to center it, I will need to translate to the middle, so half the width, half the height. And then what I do here is actually not times W, but times equalizer width to set the x coordinate of every line of this equalizer, and equalizer h. And if I want it to be centered, this value I divided by length is between 0 and 1. If I want to center it, I need to move it half, 0.5 the other side, so I just need to remove 0.5. Okay, so now we have our audio data, which is displayed centered and everything, which is nice. But we see that there's not many frequencies up here, and it's really noisy. What I would like to do is to turn this into like mountains or a canyon and fly through it. No? Doesn't sound nice? Okay, so to make it look like a mountain or a canyon, we actually need to mirror it. So what we can do to do that, we need an index, and we check if we are halfway through, we use the index. Otherwise, we say from the length, check that, or take the length -1 and decrease the index. So it will mirror it that way. So now we see the cliff on both sides. And the stroke is a bit small, so let's increase the line width. Let's use 4. It's a bit bigger, and I'm not too happy because it's really noisy up here, so I will just skip some values. Yeah, that looks a bit, yeah, that looks less noisy visually. And if we want to make a mountain, we have one slice of a mountain, but what we want to do is actually to draw more slices towards us. So to do that, we can actually stop clearing the whole canvas. We can actually do motion blur, like I mentioned before. For that, I can use just color, and now you can set the alpha like that. You can set another value, which is the alpha, and then I can actually draw a rectangle over the whole thing. So from 0, 0 for the whole width. And here, because I was setting the width which does reset the canvas, if I run the code now, you will see this thing fly this way, because I will keep translating, because I don't save and restore the canvas. Makes me lie. Yeah, no, of course it did draw, but actually Now I'm drawing, but down the screen, because I keep translating by half a screen. So what we need to do is actually to save the state and restore it at the end. Okay, so now we have like a motion blur on top of our thing, and if we want to draw or to make this thing move towards us, we just need to draw the canvas a little bit bigger, and then a little bit bigger at the next one, and so on, and then the whole thing will just move towards us. So let's define a zoom level. It says just 2%, so 1 times the size of the canvas plus 0.2 to do 2%. So we can draw image, which takes a canvas as argument. I will take the whole canvas, so from 0, 0 to W width and height, and then I will draw this because we are translated by half at the middle. I want to translate half the width times my zoom level and half the height times the zoom level. So, oops. So half the width times the zoom level, comma half the height times the zoom level. And of course, I need to specify the whole width and height of the zoomed of a target image. So that would be the width times the zoom level, and the height times the zoom level. And now we have like a canyon. It gets really crowded here, so what if we draw this only every 4th frame? So I can do this, and we can do we can check if the frame index modulo 4 is 0, draw, otherwise just skip it. So that should give a more retro look. And likewise, if we want to make it a bit more shiny, we can set the global composite operation to be lighter, which will actually accumulate the colors. Yay! Let's reset it back to. Oh, is it lighten? I keep mixing these two. No, it's not. Of course. Yeah, of course. I need to do to make things lighter or add up only when I draw the mountain. So only there when it overdraws, I want to add the colors. Not when I draw the whole image on top of itself to make it zoom. Otherwise it just goes black, white. And let's try quickly to draw some small clouds. So why not? So I want to like draw clouds randomly, like at a random x coordinate at the bottom. So I can do x of my cloud will be, and we can use the equalizer width. We can reuse it. And yeah, same as we did up here. We need to go from minus 0.5 to 0.5 to just be centered. And the y coordinate will be the height divided by something very big, so a little bit above the level. And we can set the stroke style to some cloudy color, something almost white. Well, we'll draw like a bit like a circle, but a bit broken. So we will draw again. There will be a path, like one single primitive, lines and paths here. We will need to close that path at the end to strike it. And in this case, the coordinate will be the x that we defined a few lines above, times, let's say, equalizer width divided by some numbers to make it much smaller. And what we do here, if you look at a circle, the x coordinate is the cosinus of the angle, and the y coordinate is the sinus of that angle. So if you want to draw a circle, you can just pick any angle, and the cosinus gives you the x coordinate, the sinus gives you the y coordinate. And here we have I, which goes from 0 to 6, almost 2 pi, and that will be good enough. Oops. And we'll do something similar there, but with a sinus. Yeah, one semicolon too many. So we have that. And let's add yeah, there we go. So, yeah. Then, so that was fun, but then comes the question. Yeah, I hear that a lot. Why doing this? And that's because it's pretty fun. It's pretty rewarding. I mean, you see, it was like 15, 20 minutes coding, and it was pretty cool, I think. And we'll learn a few things on the way. But it's also when you do this, you actually explore new APIs, new ways to do things, and it's you can really bring it back to your actual work to write useful code, and I do that every day at Microsoft. If you want to get started doing these kind of things, I highly recommend the Nature of Code, written by Daniel Schiffman. He's an art teacher at the School of New York, and he's also an amazing teacher who does live coding, just like that, but more crazy, on YouTube. Follow him, he's brilliant, really. So thank you so much, Randa, for having me. The music you heard is by a friend, Kenneth Deluxe on Twitter. And if you have any question, reach me on Twitter or live, I'll be around. Thank you so much, and please go code hard.